Hello everyone. In the last lecture, we have discussed one of the important topic, that is frequency reuse. Frequency reuse factor. Some important concept points regarding frequency reuse. So, the main purpose of frequency reuse in order to improve the coverage area capacity of the cellular system. So in the part of frequency reuse, just we discussed n is equal to 4, n is equal to 7, n is equal to 19, like that, depending upon the cluster size. So for n is equal to 4, so only 4 cells included in the cluster. For n is equal to 7, n is equal to 7 cells are included in the cluster. N is equal to 19, 19 cells are included in the cluster. So this is the some example. So among these three, only 4 and 7 are suitable to explain to design the cellular system. So in between them, n is equal to 7 is the very suitable. That is depending upon the integer values of I and j. Okay, now so I is equal to 1, j is equal to 2, or I is equal to 2 and j is equal to 1. So the same cell having frequency, there may be a chance of using same channels from the source cell. So this is about these are the things we have discussed in the last lecture. So now I am going to discuss about some silent features of frequency reuse. Let's start with the first one, frequency reuse. Frequency reuse improves the spectral efficiency and signal quality. So in order to measure the performance of the wireless communication system, so compulsory we need one parameters like efficiency, gain, transmitting power, reuse ratio, like that. So one of the point is spectral efficiency to improve. Next one, signal quality. The quality of received signal also will improve through the frequency reuse. So the second one is frequency reuse classical scheme proposed for GSM system, global system for mobile communication, offers a protection against the interference. So in communication system facing some interference in the normal mode. So in order to overcome that, we use frequency reuse also used to remove the interference between the required signals. Next one, the number of times a frequency can be reused. It is depends on the tolerance capacity of the radio channel from the nearby transmitter that is using the same frequencies. Next one, in frequency reuse scheme, the total bandwidth is divided into frequency subbands that are used by the cell. So the total allocated bandwidth can be divided, means automatically the capacity of the cellular system is automatically improved. So this is one of the advantage. Silent feature is nothing but advantage. So next one, frequency reuse scheme allows WiMAX system operators to reuse the same frequency set different cell sites. So these are the some silent features of frequency reuse. Next one, channel assignment strategies. So here channel assignment channels are assigned to subscribers as per their requirement. So here we have to follow some strategy methods. So here channel assignment strategies, a frequency reuse scheme is that is consistent with the objective of increasing capacity and minimizing interference is required. So in the total cellular system we have only two requirement. The first one is the improve the cellular capacity. Second one is the minimize the interference. So these are the two main domains. So the main objectives also. So here the channel assignment strategies are classified into either two types: fixed assignment strategies and dynamic assignment strategies. So in between them, the choice of channel assignment strategies impacts the performance of the system, particularly as to how the calls are managed when a mobile user is handed off from one cell to another cell. So here the channel assignment schemes are initially two types. One is the fixed channel assignment and dynamic channel assignment. So again, fixed channel assignment for fixed channel, it is fixed based. So For example, just I assigned only 10 channels for a 10 channels for a particular subscriber. So within that only the subscriber may subscribe the channels then used for their requirement. So here, sir, n number of channels fixed for particular user, particular subscriber. Okay, so it is fixed. So beyond that or above that, it can borrow from the another neighboring cell. Okay, so this is one of the disadvantage of fixed channel assignment strategies. Okay, first you can fix with some n number of channels for a particular user. Above that, it can borrow from the another channel. So it is borrowing method. It having borrowing method and hybrid. Next one, dynamic channel assignment strategy. So dynamic channel assignment strategies, above the predefined channels, it can allocated automatically depends upon the flexible mode. Okay, now so this is two types of channel assignment strategies, fixed channel assignment strategies and dynamic channel assignment strategies. So fixed channel assignment strategies having one disadvantage is so borrowing. So in order to overcome that, we follow dynamic. So the all things are discussed in the differences between fixed channel assignment and dynamic channel assignment strategies. Next, move on to the some theoretical points of fixed channel assignment strategies. So each cell allocated a predetermined set of channels. Okay, now each cell having initially it fixed for some n number of channels only. So any attempt within the cell can only be served by the unused channels in the particular cell only. Okay, now so within that cell only the cell will served. So if all the channels in the cell are occupied, the call is blocked and the subscriber does not receive any service. Next, several variations of the fixed assignment strategies are exist in one approach called the borrowing strategy. Okay, so a cell is allowed to borrow channels from a neighboring cell ID. All of its own channels are already occupied. Okay, so next one, dynamic channel assignment strategies. Some theoretical points. Channels are not allotted to different cell permanently. Okay, dynamically changing from one to many. Okay, so each time a call request is made, the serving base station requests a channel from the mobile switching center. Okay, so next the switch then allocates a channel to the requested cell following an algorithm that takes into the account. So the likelihood of fixed blocking within the cell. So these are the some theoretical points regarding fixed channel assignment strategies and dynamic channel assignment strategy. Next, what is the conclusion of from the channel assignment strategies? So accordingly, the MSC mobile switching center only allocates a given frequency if that frequency is not presently in use in the cell or any other cell which falls within the minimum restricted distance of frequency used to avoid the co-channel interference. So in order to avoid co-channel interference, here fixed channel assignment strategies may be used. So dynamic channel assignment reduce the likelihood of blocking, which increases the trunking capacity of the system. So this is the advantage of dynamic channel assignment strategy. So let's differences between the fixed channel assignment strategy and dynamic channel assignment strategy. So each cell is allocated a predetermined set of voice channel. So we already know. So the name itself, it says fixed channel assignment. So it fixed for n number of channels. So here each cell having allocated predetermined set of voice channel. So beyond that automatically will block. So the blocking probability is in another topic. So here each cell is allocated a predetermined set of voice channels. Okay, so next one in dynamic channel assignment strategy. So each time a call request is made, the serving base station requests a channel from the MSC. So it link up direct with mobile switching center. So each time a call request is made, the serving base station request channel from the mobile switching center. Next one, any call attempt within the cell can only be served. So outside the cell, call is now automatically will black. So by the unused channels in the particular cell only. Okay. So in the dynamic channel, the switch allocates a channel to the requested cell following an algorithm. Following an algorithm that takes into an account the likelihood of future blocking within the cell. The frequency of the use of the candidate channel, the reuse distance of the channel, and other cost of the functions. Next one, in fixed channel, if all the channels in the cells are occupied, the call is blocked automatically. So the subscriber does not receive any service. So it is fixed for n number of channels. So automatically beyond that the signal will be automatically blocked. So this is one of the disadvantage of fixed channel assignment strategy. Next, in dynamic channel assignment strategies, it is reduced the likelihood of blocking, which increases the trunking capacity of the system, since all the available channels in the market are accessible to all the cells. Okay. So next, in conclusion, borrowing strategy. So in order to overcome the disadvantage, just follow borrowing strategy. The cell is allowed to borrow channels from a neighboring cell if all of its own channels are already occupied. So that to avoid the co-channel interference. Next, the MSC only allocates a given frequency here. If that the frequency is not presently in use, in the cell or any other cell, to avoid the co-channel interference. Next one, computational load on the system is very less. Okay, the computational load on system is very less in the fixed channel, but in dynamic channel assignment increases the storage and the computational load on the system. Okay, so these are the some differences between the fixed channel assignment strategy and dynamic channel assignment strategy. Next, move on to the very important topic, that is handoff mechanism. So before that, what is handoff strategies or what is handoff first? Handoff means a handoff refers to the process of transmitting an active call or data session from one cell in a cellular network to another, or from one channel in another. So for example, here there is a 4 cell patterns here in the diagram, yellow, blue, cell 1, cell 2, cell 3 and cell 4. Here one car is moving from at the end of cell 3 and it entering into the cell 4. So that means the car is moving from cell 3 means it is leaving from the nearest base station, that is cell 3. Okay, it is leaving from base 3 entering into the base station cell 4. Okay, so the signal will, before initiating the handoff mechanism, I will the process will explain. So here, before initiating the handoff mechanism, so automatically the signal will last when the car is crossed cell 3. After initiating the handoff, the signal will automatically decrease from the cell 3. It is decrease means increase from the base 4, cell 4 base station. Okay, so we may lose any information while the car moving from one cell to another cell. So this is the importance of handoff strategies. So a handoff refers to the process of transferring an active call or data session from the one cell in a cellular network to another, or from one channel to another cell. Okay, so when the car is moving from one cell to another cell, so the signal, without the losing of the signal, the call will continue up to end of the call. So this is the main importance of the handoff strategies. Okay, so the cellular networks are composed of cells, each of which is capable of providing telecommunication service to subscriber roaming with them. Each cell can only serve up to a certain area and a number of subscribers. Thus, when any of these two limits is reached, the handoff is ensures. Okay, so each cell can only serve up to a certain area, the number of subscribers. So Either we increase the capacity of the base station, or we can allocate more number of channels to the subscriber. These are the some common things in the handoff. So this is the concept of handoff strategies. So what are the classifications of handoff mechanism? So here we have two types of initially two types of handoff, hard handoff and soft handoff. Hard handoff, soft handoff. So in order to remember these two things, just you can remember only one thing. So break before make for hard handoff. What is break before make? If you see the diagram here, so this is a one cell, this is other cell. Okay, so a hard handoff is actually break in the connection occurs break before make. So the first the signal will lose, or the signal will break, then only the connection will make from the second base station. Okay, that is the principle of break before make for hard handoff. So here the radio links from the mobile station to the existing cell is broken before establishing a link with the next cell. Actually, after initiating the signal from the another base station, then only the signal will disconnected. But in the hard handoff, that is the process will exist in the soft handoff. But hard handoff follows break before make policy. So before make, the signal will lose. So from that we may lose some information. So this is not suitable for us. So such as the mobile broadband. The example is mobile broadband net. Okay, so it is the hard handoff. So you need to remember the principle break before make policy. Next one, soft handoff, make before break. The first the connection established, the connection is set up from the another base station. Then only the signal will say the first connection will lose. Okay, so entails two connections to the cell phone from the two different base stations. This ensures that no break ensues during the handoff. Naturally, it is more costly than hard handoff. Okay, so the signal may no need to last. So it is costly than a hard handoff. So the policy, the principle for to remember soft handoff, make before break. Okay, so here the connection is already established through the second one. So then the first connection will gone. Okay, so this is soft handoff. Next one, some situation for triggering handoff here. So if a subscriber who is in a call, or a data session moves out of coverage of one cell and enters the coverage area of another cell, a handoff is triggered for a continuum of service. Okay, so this is one of the situation for handoff. Implement the handoff. Next one, each cell have a predefined capacity, that is can handle only a specific number of subscribers. If the number of users using a particular cell reaches its maximum capacity, then a handoff occurs. At the time only the handoff will occur. Some of the calls are transferred to adjoining cells, provided that the subscriber is in the overlapping coverage area of the both the cells. Okay, so the next one, the cells are often subdivided into some micro cells. A handoff may occur when there is a transfer of duties from the large cell to the smaller cell and vice versa. For example, here there is a traveling user moving within the jurisdiction of a large cell. If the traveler stops, then the jurisdiction is transferred to a micro cell to relieve the load on the large cell. This is one example for micro cells. So handoff may also occur when there is an interference of calls using the same frequency for communication. So these are the some situations for triggering handoff. Next one, prioritizing handoff. So here what are the prioritizing? handoff. Here we have three methods here, very important methods. So first one is the guard channel. So in the guard channel, a fraction of the total number of available channels in the cell is reserved exclusively for handoff request from ongoing calls, which may be handed off into the cell. So for example, in my channel, I have 10 channels, 10 channels to implement a handoff. So among 10, 3 and 7, just you can divide it into 3 and 7. So the 3 channels for handoff, 3 channels specific for handoff mechanism. So this is the guard channel. So a fraction of the total available channels in a cell is reserved exclusively for handoff. So out of 10, 3 for exclusively handoff request for from ongoing calls. Okay, now so this is about guard channel. So what is the advantage of guard channel is effective, efficient spectrum utilization when dynamic channel assignment strategies. Okay, so the advantage of guard channel are if we assign some specific number of channels for the handoff in a system. So the advantage is efficient spectrum utilization is we can use efficiently spectrum allocation. Next one, queuing of handoff request. So queuing of handoff request to decrease the probability of forced termination of a call due to lack of available channels. Next, queuing of handoff is possible due to the fact that there is a finite time interval between the time required time for received signal level drops below the handoff threshold and the time the call is terminated due to the insufficient signal. So in the guard channel, just we can play with some n number of channels specific assigned for handoff request. So in the queuing of handoff request, just we can play with the time interval between the received signal level drop and threshold time. Okay, so what is the disadvantage for queuing of handoff request? Increased new call blocking probability. So the blocking probability will increase automatically. That will affect of the capacity of the system. So this is the disadvantage of queuing of handoff request. Next one, here high-speed vehicles pass through the coverage region of a cell within a matter of seconds. So here one term is in terms of practical handoff considerations, cell dragging. So it is very important term, cell dragging. So some high-speed vehicles pass through the coverage area of a cell within a matter of seconds. So high-speed vehicles are moving with some high speed. So whereas the pedestrian users may never need of a handoff during a call, particularly with the addition of microcell to provide the capacity. For example, a pedestrian user walking on the road. So in the beside there is a car or any other vehicle will move with a high speed. So at that time, the pedestrian user may lose the information. If you use microcell concept there, so they may not lose any information at that time. Okay, so that is the microcell concept that we'll discuss in the next slide. So the MSC can quickly become burned if high-speed users are constantly being passed between very small cells. Next, another practical handoff problem in microcell system is known as cell dragging. So even though cell dragging results from the pedestrian users that provide a very strong signal to the base station. So for example, here this is a one cell here. So this is one another cell. So one person is moving from this cell to this cell. So even though the person is at the outside of the cell, the person is outside of the cell is having strong signal from the base station of first cell. Okay, so this is the cell dragging. So such a situation occurs in an urban environment when there is a line of sight path between the subscriber and the base station. So what is line of sight? So the transmitter is exactly in phase with receiver. That is about line of sight communication that we will discuss in future. So to solve the cell dragging problem, handoff threshold and radio parameter coverage parameter must be adjusted carefully. So in order to design any cellular system, we follow some we have to maintain some parameters at a particular stage. So here to solve the cell dragging problem also, handoff threshold, radio coverage parameters, so many parameters to implement that, so that adjusted carefully. Okay, so another practical handoff consideration is umbrella cell pattern. It is very important topic. So by using different antenna heights, different power cells, it is possible to provide large and small cells which are co-located in a single base station. The technique is called umbrella cell approach. It is used to provide large area coverage to high-speed users while providing a small area coverage to users that are traveling at low speed. So umbrella cell pattern means it look like umbrella. It covers large area for high-speed users only. So let's see one example here. So the below figure illustrates the umbrella cell which is co-located with some smaller micro cells. The umbrella cell approach ensures that the number of handoff is minimized for high-speed users and provide additional micro cells for pedestrian users. So here the cell size is just you look at the diagram once. So it is umbrella pattern. So umbrella pattern means it provides some security or it provides coverage for high speed users. It is okay. So here there is a 1, 2, 3 green color cells are micro cells. Each micro cell having each base station. Each micro cell having individual base station. So that is for pedestrian users only. Okay. So when the large cell for this is umbrella antenna. Just you it is called umbrella antenna. So let's see one example here. So from here to here, one pedestrian users moving from here to here. Pedestrian users means he is having only having a low speed. So from here to here, initially the micro cells are for pedestrian users. For high speed users like car, any other high speed users, protected by umbrella cell approach. So it covers look like umbrella. It covers entire region for high speed users. Okay. So from this topic, just I can conclude with 2 sentences. So for high speed users protected by umbrella cell approach, pedestrian users can covered by micro cell zones. Okay, so this is about practical handoff considerations. Next, this is the diagram for it is illustration of a handoff scenario at the cell boundaries. So proper handoff installation and improper handoff installation. So the differentiate to describe the differentiate that two terms. Okay, so it is proper handoff situation. So the signal at a point is here. So improper handoff situation. So the signal from here to here. So is there proper hand? There is a improper handoff. So the signal will automatically terminate from the at the point B. So if you maintain proper handoff situation, so the signal will automatically transfer to the at level point B. Okay, so this is the difference between improper handoff situation and proper handoff situation. So the a car is moving from A to B. Okay, so if you maintain proper handoff situation, the signal will automatically transfer to the another base station. If you maintain improper handoff situation, the signal will directly call is terminated at the level at the point B. Okay, so this is the differentiation between the proper handoff situation and improper handoff situation. Next illustration of these are the words regarding this diagram. The first figure demonstrates the case where a handoff is not made. The signal drops below the minimum acceptable level to keep the channel active. This dropped calls event can happen when there is an extensive delay by the MSCs assigning a handoff may occur during a high traffic conditions due to computational loading at the MSC. Next, the time over which a call may be maintained within a cell without handoff is called the dwell time. The dwell time for a particular user is governed by a number of factors, including propagation, interference, distance, and the subscriber the base station. So these are the terms regarding the this diagram here. So we use some generation methods. The first generation analog cellular system. So in the first generation of analog cellular system, the signal strength measurements are made by the base stations, supervised by the MSC. Next, each base station constantly monitors the signal strength of all of its reverse voice channels to determine the relative location of each mobile user with respect to the base station tower. Next, second generation system. In the second generation system, handoff decisions are mobile assisted only. MH mobile assisted handoff. In mobile assisted MAHO, every mobile station measures the received power from the surrounding base stations and continuously reports the results of the measures to the serving base station only. So this is about first generation of analog cellular system and second generation of system. Okay, so second generation system is also known as mobile assisted MAH. So basically handoff strategies are mobile assisted handoff, mobile controlled handoff, network control handoff. So these are the three basic handoff strategies: mobile assisted handoff, mobile controlled handoff, network control handoff. So each having some specifications through the first generation and second generation systems. Okay, so in the mobile assisted handoff mechanism, it covers only base station. The network control mobile along with the area, and network control handoff it monitors the entire network as per the requirement. So these are the three handoff strategies: mobile assisted handoff, mobile controlled handoff, network control handoff. So here handoff decisions are mobile assisted. It is known as MAHO, mobile assisted handoff. Next one, second generation system. MAHO methods enable the call can be handed over between the base stations at a much faster than it's the first generation analog system, since the handoff measurements are made by the each mobile, and the mobile switching center no longer constantly signal strength. And MSC engages in an inter-system handoff when a mobile signal becomes weak in a given cell, the MSc cannot find another cell within the system. So this is about second generation system. So these are the handoff mechanisms, soft handoff and hard handoff, handoff strategies, mobile assisted, mobile controlled, network assisted handoff mechanism with some real time examples. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.